Hello, class. Greetings from Brooklyn in New York City. I have a head cold and there's construction going on outside, so we'll see how things go here. Just to remind you, though, we started our discussion of fish, whoever they are, in class on Monday. I want to go briefly through, some of the taxonomy and characteristics of the main groups of critters we call fish. And then on Friday, we'll look at more specifics of the Sarcopterygiae, well, actually, of the Neopterygiae. We'll look at a couple of vodcasts and have clickers, so it'll be great. To remind you, we established that fish are, kind of a messed up grouping, by probably nobody's estimation monophyletic. And there's clues to that when you look at how they group on phylogenetic trees, and also the fact that we classify them based on, what they are not. In other words, they're vertebrates that are not tetrapods. They are aquatic vertebrates that may have gills, that may have appendages in the form of fins, and that may have ectodermally derived scales. And they include the Myxini, are the hagfishes, the Petromyzontids, are the lampreys, the Chondrichthyans, sharks, skates, rays, chimeras, the Actinopterygians, the largest group of what we would call the bony fishes, and the Sarcopterygians, a small group of fish, but the rest of us tetrapods belong to the Sarcopterygia. You've seen this chart a bunch and know that it's very important. And as you can see, right now we're within the Gnathostomata, moving our way from left to right. We'll first talk about the Chondrichthyes. Actually, that's a lie. I'm going to say something about the Myxini and lampreys as well. And we've seen this before. This graph from your text just gives you an idea about the evolutionary radiation of these groups of fish. And you can see the modern bony fishes are really in their heyday in the Cenozoic or modern era. This graph, or this table of the craniates, is great, and we're going to start with the left, the Myxini or the hagfishes. They have all the craniate characteristics like a distinct head, a tripartite brain, the cranium that encases the tripartite brain, and a well-developed skeleton. The hagfishes are characterized by slime glands and accessory hearts. And they have a mouth surrounded by barbels, which can be used to grasp onto things. They use the keratinized teeth on their tongue for scraping flesh. They're scavengers, basically, although they do feed on live organisms as well. I've got a video of them feeding.
The very bottom of this deep sea, but even there, its flesh will not be wasted. Over a mile down, in the total darkness of the deep ocean, the body of another grey whale, a 30-ton adult. It settled here only a few weeks ago. Already, it has attracted hundreds of hagfish. These scavengers, over half a metre long and as thick as your arm, are only found in the deep sea. They have been attracted by the faint whiff of decay suffusing through the water for miles around. With their heads buried in the whale's flesh, they breathe through gill openings along the sides of their bodies. They're very primitive creatures, not even true fish, for they lack jaws. They feed not by biting, but by rasping off flesh with 2 rows of horny teeth. In just a few hours, a hagfish can eat several times its own weight of rotting flesh.
And I mentioned they're famous for their slime. This is a really good illustration of what that slime can do.
Now it's recording. We have 180 seconds.
Okay, yeah.
So I'm collecting some slime.
Yeah.
Can you see?
Oh, yeah.
Mix it. And my official mixing apparatus, let me hold it up.
You got to back
Everybody
off a
can
bit.
see.
Wait a minute. Well, okay, go for it.
And the entire beaker.
Wait a minute. It is empty. Turn the beaker upside down and pour it out. Nothing.
There you go.
Some work recently done with hagfishes discovered the presence of a reproductive hormone, or a gonadotropin, like we use during our gamete generating cycles, which they claim represents a significant step toward unraveling the mystery of hagfish reproduction. One of the things I thought was interesting is that the reproductive functioning of these ancient vertebrates is such an enduring enigma that a gold medal was once offered to anyone who could elucidate it. Fascinating. Lampreys, we've seen a bit of. There's plenty out there about sea lamprey destruction, what they did, for instance, to the lake trout fishery in the Great Lakes, and then different attempts to control sea lamprey populations. I'm going to refer you to the vodcasts that were presented in class. They're great and tell the story better than this PSA. So basically, hagfishes and lampreys, note, they lack paired appendages, they have fibrous and cartilaginous skeletons, and they lack jaws. Okay, the way they deal with the absence of jaws is that the hagfish have keratinized plates on their tongues, and the lampreys have a sucker-like oral disc, which also has kind of keratinized teeth, which can be used for scraping at flesh. Now we move into the jawed organisms, the Gnathostomata. Their second visceral arch basically moved forward throughout their evolutionary history and became a supporting element for strong muscles and led to the development of jaws. We also see teeth with dentine, so the similar tooth structure to what we have. The elasmobranchs are a clade within the chondrichthyes that includes the sharks and rays. They have a predominantly cartilaginous endoskeleton, and they have placoid scales that are very tooth-like. I will show you a figure of that from your book in a little bit. They have exposed gill slits, and they lack a gut-derived swim bladder or lung. They have separate sexes with internal fertilization, so boy and girl sharks, and lacking the lung, lacking that ability to mechanically or use muscular contractions to move air around, they're dependent on keeping water moving over their gill slits. So even when they're sleeping, there's a little bit of movement in sharks and rays. This lateral line system that characterizes chondrichthyes and other fishes hopefully was pointed out in lab. The lateral line system detects vibrations, and the ampullae of Lorenzini basically have these little jelly-filled canals which amplify electrical signals from the surrounding waters. It's amazing what they're able to detect. It's thought that the predatory cycle of sharks begins by detecting potential prey using the lateral line system. They hone in on the prey with vision and then use bioelectricity to complete the kill. The different fish we'll talk about are characterized by different types of tails. Sharks have heterocircle tails. The lungfish have what's called a diphthcircle tail, and we won't look at really any of those. And most of the fish we're looking at, the neopterygians have a homocircle tail. Okay. The holocephali include the chimeras. There aren't a ton of them. There probably were more in our past. They have a cartilaginous endoskeleton. They have, again, placoid scales, but they're really reduced in adults, so they seem kind of soft and fleshy, as opposed to, you know, the sandpapery feel that you may have experienced with sharks. They have the polyphyodont teeth and exposed gill slits. They lack the swim bladder or the lung. They're clearly similar in many regards to the elasmobranchs. They're very, very odd looking critters.
Holy mackerel, look at that thing. That's amazing.
Note that this video was taken at 600 meters deep. Few people get to see the chimeras. Okay, so now we move into the things that have a gut-derived lung or swim bladder. That includes what was formerly called osteichthyes, two groups of fishes, Actinopterygii and Sarcopterygii, and the tetrapods. Tetrapods and Sarcopterygii share common ancestry, and many fold the tetrapods, all of us, into the Sarcopterygii. We have an endoskeleton composed primarily of bone and other features that unite us. Just a minute. So the dominant vertebrate group are within the Actinopterygii, the bony fish. They can have different types of scales. They can lack scales or have cycloid or ctenoid scales. They have long dermal rays or lepidotrichia that support fins. They use a swim bladder for buoyancy. Most of them. Some lack the swim bladder. And the gills are supported by arches but covered with a bony operculum, which is a really nice feature, especially for benthic dwelling fish, to keep sand and sediment out of their gills. In most cases, sexes are separate and they have external fertilization, but there are exceptions to this, and some really cool ones such as protandrous hermaphroditism and clownfishes, etc. And here you can see the scales that we've been talking about straight out of your book. You've got the placoid scales on your left that characterize the elasmobranchs and the holocephali. The cycloid and ctenoid scales on the right are what occur in most of the fish you'll see and discuss. The Actinopterygii includes three clades, the Cladistia, the Chondrostii, and the Neopterygii. And the Neopterygii includes the teleos, or the modern bony fish, the largest group of modern vertebrates. And I would remind you to check out the characteristics from your text. A few things we'll point out. They typically have a homocircle caudal fin or tail, a skeleton composed mainly of bone. They have cycloid or ctenoid scales in modern forms, the lepidotrichia. They have muscles that control these lepidotrichia. They have jaws present, very big deal, swim bladder, and an operculum that covers their gills. And I'm pointing out just the location of the swim bladder. This is a very big deal, and hopefully in your dissection of the perch, you would have been able to see this. It's pretty amazing how these work. Basically, very small muscles that can constrict to allow gas exchange connect with networks of capillaries to take air out of the bladder or puff it up when needed. Again, there are fish that lack the swim bladder or actual actinopterygii that do, such as the bottom-dwelling, flounders, deep sea, large deep sea fishes, etc. And then the Sarcopterygii is where we will stay for the rest of the class. This includes some famous extinct fishes as well as a few extant fishes like the African lungfish. And I will show you a really great video of them.
Pull on those gardening gloves. Grab the nearest spade. And let's see how colorful...
Actually, I think I have it already loaded. Let's go here.
Extraordinary abilities. It's the lungfish, and while it has gills like any other fish, it can also breathe air directly using a modified swim bladder that acts as a lung. When water levels are high, this isn't so important, but the rains will eventually fail, and the constant burning sun will dry up all the water. Fish are left flapping at the surface as the waters disappear. Only the air-gulping lungfish is able to cope with these extreme conditions, but it's still exposed to the heat and is still at risk from predators, so it relies on another, even more extraordinary ability. It finds a new, safer home buried underground, digging down by eating mud and pushing it out through its gills. To stop it drying out, the lungfish exudes a special mucus from its skin, covering itself in a thick layer that hardens to form a waterproof cocoon. Only a single hole is left for breathing. Baked into this mud sarcophagus, the lungfish slows its metabolism to 1/60th of its original rate, relying on its muscles and body fat as a source of food and water. It becomes just another piece of hardened mud, and lungfish have even been known to end up as an accidental brick in a mud hut wall. But this isn't the end for the lungfish. It can survive like this for an incredible 4 years. Eventually, it could end up poisoned by its own waste products. But in this case, the onset of the rains is its salvation. As the mud walls are washed away, the lungfish's hard mucus lining is softened. It's been 4 years since it last used its muscles, and they're very weak. But as it breaks free of this mud cocoon, it still manages to drag itself towards the nearest source of water. It's the ultimate survivor. And although it's underwater now, it'll soon be back in the mud, repeating the whole process again and again as the annual rains come and go.
Cool. And they have fleshy lobed fins